So on this lovely day, we are going to be finding arc lengths in a circle, not the measure, not arc measure, but arc length. So we have to distinguish between the two. So to review, dia means through. Dia means through. So diameter is the distance through the circle, and diameter has a length. Radius has a length from the center to the edge of the circle. Circumference is the distance around, always measured in units, like meters, kilometers, inches, miles, etc. And arc measure is always degrees. Always degrees. Because an arc measure is defined by the central angle. Defined by the central angle. Central angle. So looking over here, if I have this particular arc measure here, whatever the angle is in the central angle, then the corresponding arc has the corresponding angle measure, 40 degrees, always degrees. So in contrast, arc length is the distance of that arc. The distance of that arc. So, taking a look here, and let's call these A and B. The arc measure of AB is 40 degrees. But the arc length of arc AB is a piece of the circumference. We don't know exactly right now. It's going to be inches or meters, and that's all defined, of course, by the circumference. It's a piece of the circumference. So that brings us to arc length corollary, in case you forget what corollary means. Corollary just means sub-theorem. That is, it's a thought that comes from somewhere else. So if we have circumference, arc length corollary is just piece of the circumference. So, any arc AB has a length of so that's an L. I just make it a cursive, so it's like a slanted L. It's the measure of the arc over 360 times circumference. In other words, we say a piece of the circumference. It's a piece. Did you walk around the whole circle? No. How much of it did you walk around? Oh, I only walked around a quarter of it. Oh, you walked around a quarter of it. That's your piece, 1/4. I walked halfway around that circle, 1/2 of my circumference. So generally, we're going to put a degree up there, 20 degrees, 50 degrees, 300 degrees, or if it were halfway, we'd say 180 degrees. Let's take a gander at this first one. We're asked to find the length of this. We know the measure, it's 90 degrees. We know the measure, it's 90 degrees. Therefore, we now know the piece. We know the piece. So I'm going to say L for length, the length, and my piece is 90 degrees, and it's always going to be over 360. Now some of you say, oh, I know that's a fourth. Well, you could have written 1/4 then. I'm just writing it out using the corollary. And then we say my circumference. Since I am given the radius here, I'm given the radius, I'm going to use 2 pi r. So it's times 2 pi, and my radius is 7, so times 7. Again, I chose to use the 2 pi r here because the radius was given, not the diameter. Okay, now notice, many of you notice that, of course, this can be divided by 90, and this can be divided by 90. So effectively, we're looking for 1/4 of the circle. And of course, the 2 times 7 is 14. So I can get 14 pi over 4. And again, I can reduce one more time, divide by 2. 7 pi over 2. Now that's my exact answer. That's my exact answer. And I'm using inches here. Now the approximate answer, we just plug into a calculator. So it looks like it rounds up to 11 inches. So I have two answers. This is my approximate value, and this is my exact answer. And if it does not say which to leave it in, you should do both. Set this one up. As said, the piece of my circle is 120 degrees, and the circumference is 2 pi r, r being 6. And so let's simplify this one. Clearly we see the zeros drop out, and then from there you can see that 12 is 1/3 of 36. And you could even still go on by killing that one. And now we can multiply out. Here we see that we have 2 times 2 with pi. So my exact answer is 4 pi feet. And then when you multiply out, you get 12.57 feet. And both of these are my answers. One is exact and one is approximate.